Good evening and welcome to Lowell Observatory and our ongoing celebration of this telescope right behind me, the Clark 24-inch refractor here at Lowell Observatory. My name is Kevin Schindler and I'm the historian here at Lowell Observatory. And this has been a fun year celebrating this telescope because it has such a great heritage going back 125 years. The cutting edge research that was done with it for so long, the education that's done with it today, inspiring people from around the world to explore the heavens for themselves. And then the world attention that comes to Lowell Observatory through this telescope with people that have visited it, media that have come here, film crews that have come here and so on. So this has been a really great celebration this year. This is our last episode of the celebration this year, but we're pleased to announce that next year happens to be the 10th anniversary of our modern go-to telescope, as it were, the Lowell Discovery Telescope, our massive 4.3 meter telescope, the fifth largest in the continental US, and one of the most powerful telescopes in the world. We've been using this for 10 years now. It seems like it was just yesterday. So next year, we're going to do a kind of a similar series where every month we're going to bring in scientists and talk about the research that they're currently doing with the telescope. We'll do some live feeds from out of the telescope also. So tonight for our final celebration, I'm honored to have a couple people with us. First of all, the other fellow you see on the screen is Dave Eicher, who for so many people doesn't need an introduction. He is one of the world's leading experts in astronomy. He's been the editor-in-chief of Astronomy magazine since almost going back to when this telescope was built, or at least a long time. And Dave is also on the advisory board here at Lowell Observatory, and also just got back from Antarctica to view the solar eclipse, and he seems to be functioning very well. So we'll be bringing in Dave to talk a little bit later. And then behind me out of the screen is Sarah Bircher, who heads our education program up here tonight. And Sarah is doing all she can to will the clouds away. If she can do that, we'll have the telescope set up on Merope if we can, which is a star that we're going to talk about a little bit later, that has a lot of importance with research that was done with this telescope and research that kind of changed our understanding of the size and the age of the universe. So in the next 45 minutes, we're going to be talking about a lot of different things. Maybe look through a telescope if you can. If not, we're sure going to talk about it. So for those watching, if you have any questions, send those in. And Heather Craig, who is behind the scenes doing everything tonight, and doing a great job, she'll pipe those to us, and we'll get to questions as we can. So we hope you sit back and relax and help us celebrate this telescope. Now throughout the year, we've talked about different aspects of the telescope, the history of it, how it was built, some of the unique characteristics like that the dome sits on 4 tires, and at one time it floated in salt water on pontoons, and that there's bicycle chains still used to operate it. There's a lot of quirky characteristics. And we've talked a lot about the research that was done with it, because this is one of the most storied telescopes in the world because of the first evidence of the expanding universe, Percival Lowell's studies of Mars, and his pursuit to prove that there was intelligent life there. Astronauts training on here in preparation for going to the moon in the 1960s. And millions of people today who look through this and get inspired. So it's really a storied telescope. We've talked about a lot of things. And so tonight, kind of as our last month of celebration, we thought we'd share some of the famous people who have come through here and look through this telescope because I mentioned that it was a storied telescope. And of course, that starts with the research that was done here. But also just the number of people that have seen this telescope or looked through it, and the number of people who have heard about it because it's been featured on TV shows and educational programs going back to the 1950s into today. So it's really a pretty remarkable story. So let me share my screen here, and we're going to talk about some of the, some people that you might be familiar with that have looked through the telescope. Well, this is a pretty bad picture. All we see are butts in the back of heads. But this is the telescope that's right behind me. This picture was taken in 1905. And the fellow on the right is our founder, Percival Lowell. And the fellow on the left, his name is Albert Michelson. And Michelson was a very important early physicist, astronomer, who did a lot of work with interferometry. And today, we have the Navy Precision Optical Interferometer that we operate in conjunction with the Navy and the Naval Research Lab. And that's thanks in part to the work that this guy did way back then. So it's neat to have a picture of him when he was visiting here, even though it's from his backside. Gosh, name an astronomer in the last 125 years, and they've probably been here for research or for a meeting or whatever. We don't have pictures of a lot of them, but Edwin Hubble visited here several times. He's certainly very well known. And others, this is a more modern example. This fellow's name is Frank Drake. And if you might have heard of the Drake equation, which is kind of looking at the possibility of life in the universe. This is the guy that came up with that. So this is Frank Drake back in the 1990s. So we've had scientists through the years, politicians going back to the beginning. If you're from Arizona, you're familiar with the name Henry Fountain Ashurst. He came up here and viewed through the telescope. In more modern times, when Hillary Clinton was the first lady, she was out here on a preservation tour. In fact, she named this telescope as one place that had to be preserved that was important to American heritage. In more modern times, just a couple years ago, John McCain was here, just I think the year before he passed away. And this is him, some nerdy guy showing him the telescope. And it was a really great visit to have, really an American hero here and to be able to share some of the stuff we do with this telescope. Scientists and politicians, astronauts have been here. Going back to the first American astronauts in 1963, the second group of astronauts, the new nine, the next nine, that included Neil Armstrong and Jim Lovell, Frank Borman and others, they came here in 1963 in January to kind of see if it was worth doing geology training in this area. It turned out it was worthwhile, and all the astronauts who walked on the moon did geology training right here in Flagstaff. Well, on that first trip, the fellow that's looking through this ocular device is Ed White. He would go on to become the first American to walk in space. He viewed through this telescope as well as some of his fellow astronauts. I should point out that this fellow behind him is Frank Borman, and Frank Borman graduated from Tucson High School in 1946. So a nice Arizona tie. And he was the starting quarterback on the state championship Tucson High School football team that year. And I don't know, 5'8" or 5'9", I think, but he still was the starting quarterback. I think he threw it like 3 times. In more modern times, this is Bill Sheehan on the left, a friend and a very successful space historian. In the middle is Bill Anders. Bill Anders was on Apollo 8, the mission that flew around the moon on Christmas in 1968. And he's the one that took the famous Earthrise picture that kind of inspired us to look at Earth and want to save it and take care of its ecology. He was here a couple of years ago, and we did a tour here at the telescope. In more modern times, Nancy Curry Gregg, who flew in space 4 times aboard the shuttle. And I show her because in just a couple of months, Nancy is one of our guest panelists for our Eicher Pluto Festival. And that goes from February 12th through 21st. And the highlight of that event is a panel discussion on February 18th at the Orpheum Theater here in Flagstaff. And we're going to talk about the human fascination with discovery and exploration. And we're going to have Nancy, Don Johansson, who discovered the fossil hominid Lucy, Alan Stern, head of New Horizons, Kathy Olkin, who's the deputy in charge of the Lucy mission, and Al Tamba, Clyde Tamba's son. So that's going to be a really fun event. I was mentioning before how so many people around the world, if you haven't been to the telescope here in the observatory, you might have seen it because of so many educational programs that have been done through the years. And that started with Walt Disney in the 1950s. Walt Disney himself wasn't here, but Ward Kimball, one of his key illustrators who did the drawings for Jiminy Cricket, among other things. He created Jiminy Cricket. He was here as part of a Mars special that included Werner von Braun, E.C. Schleifer, the Observatory, and some others. If we jump ahead, so many people know this face. This is Carl Sagan, and he was here for one of his episodes of Cosmos. Jumping ahead further, Mr. Spock on the left, Leonard Nimoy, years after he did Star Trek, he did educational programming, and here he is interviewing Carolyn Shoemaker at the Clark Telescope. More modern times, that nerdy guy showing up again, Bill Nye the Science Guy, and this guy with his billboard for the Cleveland baseball team that actually was good at that time. And Neil deGrasse Tyson, in more recent times, was actually not here to do programming or anything, but was just here on vacation. So we got a picture with Todd Gonzalez, one of our lead educator here at the observatory. And then if you listen to NPR, Ira Flato, who does Science Friday, he was here a couple of years ago doing a live broadcast as part of our Festival of Science. And here he is with our director, Jeff Hull, on the left. And I have to throw in a couple of goofy ones. The fellow on the left is one of our longtime volunteers, Rich Bonner. And on the right, that's Bernie Coppell, who played Doc on Love Boat, among other things. And then some other folks that were here, Robert Frost, Zane Grey. Just, you look through our old guest books and it's really fascinating to see who's been here. And if the Wienermobile has been here, you've hit it big. One last picture I want to show you of some well-known people is this one. And this is a great picture because on the right, we have Brian Skiff, longtime astronomer here at the observatory, who knows more about the night sky than maybe the rest of our county here in Arizona. Sarah, who is operating the telescope right now, right behind me, Gerard Van Bell, one of our astronomers here. On the left is Curtis, another one of our outstanding educators, nerdy guy here. Brian May, who has his PhD in astrophysics and also plays in a band of some sort. And then this guy right here, of most importance, Dave Eicher, who's joining us tonight. And Dave, maybe you can fill us in about the astrophysicist as I turn off the picture.
Well, thank you. Everyone has to have a hobby. So guitarists, some of them are interested in the universe and take up astronomy, on the side. Brian actually was almost done with his PhD, in the Canaries, and to the horror of his family in 1970, with it 95% done, stopped his PhD work and joined this band. But it all worked out okay in the end. So he actually went back and finished his PhD 35 years later and became Dr. Brian May.
So he's a lead guitarist of Queen. He's a PhD in astrophysics. He's one of those people, like our director, Jeff Hull, who is just, every way you look at him, he's multi-talented. And it's really remarkable. And you've written multiple books with him now. And so you've had a lot of time with him.
Yeah, he's a wonderful guy, very smart, almost never sleeps, is always working on 1,000 projects at once, and one of our heroes because he's a very bright guy and has gone through everything you can imagine in life, but he's a very warm and kind guy, as you know too, Kevin. So the world needs more people like Brian May.
We're gonna listen to some noise for just a second here, because Sarah's gonna move the dome. And she's not just making that noise so you don't have to listen to me talk, but also because the opening in the dome is only so wide. And so the telescope tracks to follow objects in the sky, but the dome doesn't. So eventually the telescope will keep moving until it's looking at the ceiling. And that's not very good to look at. So once it gets close, we have to move the dome. So it keeps looking at the opening. Even though it's still cloudy, Sarah's still giving it the old college try. And we do have a view? Oh, Sarah says we do have a view of Merope. Yes. And so this is a good introduction, Dave. Merope that's a weird star. Who's heard of Merope unless you're really into astronomy? But it really played a big role in one of the discoveries that was made with this telescope with Besto Melvin Schleifer, VM Slipher.
It's a relatively little known star, but it's a member of a fairly well-known, very tiny group of stars, the Pleiades star cluster, sometimes called the Seven Sisters, because with really sharp vision, many people can see seven stars with their naked eye alone in a tiny little dipper shape configuration in Taurus. And
On a just quick a cultural note, if you drive a Subaru car, the emblem of Subaru is the Pleiades because the Pleiades, Subaru is Japanese for the Pleiades.
Indeed. It's powered the automobile industry as well as a lot of astrophysical discovery. And it played a big part with one of the great figures of Lowell Observatory history there. It's such an honor to join a good pal of mine who's also in one of my favorite places in the world right now. But it was VM Slipher who came from Indiana in 1901, I believe it was, from to the observatory, and he got involved in studying the rotation velocity of Venus's atmosphere fairly early on. He studied spiral nebulae, as they were known at the time in the early first few years of the 20th century. And he started looking with this incredibly nice spectrograph that was built by the astronomer and instrument maker John Brashear in Pennsylvania, a very nice instrument on the 24-inch Clark, which is right behind you, looking at stars and looking at spiral nebulae and their velocities of how they were moving. And also he looked at Merope, and you talked about Merope and the Pleiades. This was in 1912, a key year, his big year of discovery. And he used what's now called the Schleifer spectrograph, and is famously on display in the collections center now. And he detected dust, or as he called it, pulverulent matter. Here it is, one of the strange words of all time, I think, in the English language. Noah Webster, I think, with us would say, "What did you just say?" Pulverulent matter, which means consisting of fine or powdery matter. And what he did was detect that there was dust inside this star cluster. And in that key year of 1912, he fixed up this spectrograph, and he put some faster lenses into it and improved it from its earliest years. And that enabled him to discover that there was dust within this cluster. Well, that was a momentous, incredible discovery, one of a couple that he made in that same year, really, actually, VM Slipher, because no one up to that point knew that there was anything at all, any kind of matter at all between the stars. That was an incredible breakthrough discovery that changed in years to come what we knew about the universe, about stars, about how they evolve, about eventually how galaxies were discovered, which we'll talk about a little bit later, and how they behave, if you will, and how things happen in galaxies. This was a milestone, keystone moment in understanding the universe, the fact that he discovered what came to be called then the interstellar medium. So this was a huge moment, and it was with this telescope behind you and with the star Merope, which has most of this, what astronomers call reflection nebulosity, dust around the star, that he discovered.
And before we get to the second part of his annus mirabilis, I guess, there's also interstellar gas that he proved the existence of. Maybe we can talk about that a little bit.
Yes, there is. And of course, we now know that the universe is the greatest recycling program that there is. And of course, low mass stars eventually give out, and stars have, finite lifetimes, just like people do, if you will, analogously. Very low mass stars live for a long time. But, as they say about some of those rock stars, the more massive, the more heavy, the more in the spotlight, the more incredible, they live fast and die young, those massive stars. So there's always gas being shed by stars and recycled into new generations of stars and into gas and dust clouds. And so that was a key moment in sort of understanding stellar evolution, this discovery by VM Slipher with the telescope. And interestingly enough, for a long, long time, people thought that the dust in the Merope Nebulae and in and around the other Pleiades stars, Pleiades, was left over from the formation of this star group, which has about 1,000 stars in it and is about 100 million years old or so, the Pleiades. But it turns out the velocities of the dust and some of the gas are different than those of the stars, the motions. So this is a coincidental thing. It appears that the cluster is moving through this cloud of dust and is not associated with it. And it was a coincidence that Vesto Schleifer was able to make this detection.
So let's think about this. We've talked about, if an astronomer made one of those discoveries, that was a pretty good year. It was doing pretty well, or maybe a pretty good career for some people. But VM Slipher was experimenting with doing spectroscopy, and it was something that nobody had really done before. They'd done it with stars, but to look at these faint, distant, fuzzy things that you started talking about before, and to do exposures that were dozens of hours long. Let's talk about that a little bit, and what he discovered by doing that.
Well, he was really, really clever, and he understood what had to be done to take very good spectra of stars and of these fuzzy circular nebulae, which many people at the time thought were proto-solar systems forming that were relatively near us.
And in fact, it's like Percival Lowell asked him to look at those because he wanted to try to prove the connection between these things and our solar system. And he was in the middle of not just trying to prove there is life on Mars, but putting it in that context of the evolution of planets.
Exactly right. Yes, indeed. And let's step forward just for a moment, and then we'll step back to the year 1912, that miracle year for VM Slipher again. But of course, a lot of big press happens, from all of us who study astronomy in October 1923, when in Pasadena, Hubble imaged and found that there was a particular kind of so-called Cepheid variable star in the Andromeda Nebula, and really proved beyond the shadow of a doubt that these spiral nebulae were distant, very large star systems. However, VM Slipher was cataloging spectra of these and understanding that most all of them were receding away from each other at high velocities 11 years before that. So he was, because of the quality of this instrument and his cleverness of understanding what he was doing, was taking very high precision measurements of both these stars and of these spiral nebulae before they were known to be galaxies, before anyone else was. And he actually measured a velocity of the Andromeda Nebula toward the Milky Way for the first time at high precision of 300 kilometers per second. And everyone thought that was ridiculous. Most astronomers didn't pay attention to them at that time. Well, it turns out it's still essentially right, that measurement. So VM Slipher at Lowell, right behind you there, and with the famous spectrograph, really was ahead of his time in terms of both his cleverness, what he thought was going on, and the precision of the measurements that could be taken by him, and with that spectrograph.
And it was really when Hubble came along. I mean, Hubble was clearly doing his own work, but he was a great synthesizer. VM Slipher was making measurements, but then somebody like Hubble was really looking at the big picture, and brought in, how do we measure the distance of these objects, and a lot of different factors.
That's right. And you're right. He was a synthesizer. Now, by 1921, this was still before the Hubble, Hooker telescope discovery. By 1921, VM Slipher had made 41 high quality galaxy Doppler shift measurements. I mean, he had a whole catalog of velocities of what turned out to be galaxies, and suspected what the universe, knew the universe was expanding, really. And he also, by that time, was making good rotational velocity measurements and understanding how these things were rotating. So he was well ahead of Hubble, really conceptually, even though Hubble, gets much of the credit because of the Andromeda galaxy discovery in the cosmic distance scale and such, you know.
I think before I go on, I think it's kind of fun to think about this for a second. We're talking about taking measurements. And, some of this work that Schleifer is doing with looking at the spiral nebulae, the first big work he did that was in December of 1912. Right now it's 32 degrees in here. It's supposed to get down to 13. And these measurements he made, he would start an exposure. So he has a telescope. He puts the spectrograph on the end instead of the eyepiece, which is capturing spectra photographically. And he has to guide the telescope because it's tracking with electricity, but it still might have a blip in electricity or move at the wrong rate. So he has to be looking through a guide telescope the whole time, making sure it's moving at the right rate. And so in some cases, he does this for several hours, looking through an eyepiece, and over several hours, the telescope tracks till the object is too low to see, closes everything down. Next night, moves the telescope as the thing is rising, puts it back on there, and continues that exposure for hours at a time. Nobody had done this, and nobody was crazy enough to do it, maybe. It's almost unfathomable to think of just the attention to detail, the focus, the patience, and then, oh yeah, maybe it's 15 degrees in here. Trying to deal with that also.
It's an incredibly difficult challenge. And if we think of the birth of astrophysics really in about the time of the American Civil War, the development of understanding spectroscopy and so on, and modern astrophysics, several hundred years after Newton and so on, really beginning, then it really there wasn't a lot of traction for a long while. There were early photographs and there were very primitive, low grade spectra and other measurements. And it was sort of experimenting with all the techniques. Well, you could say, in a sense, VM Slipher, not only was he clever and he had good instrumentation and landed, fortunately, in exactly the right place, but he came in really, you could say, exactly at the right time to really make some substantial progress for the first time after some decades of just the infancy of astrophysics, which really didn't get a lot of traction going. So, he really had it all at the right time in the right place and was good enough to make high precision measurements, which really hadn't been done before.
And one of the things you mentioned also is worth going into a little bit more. You said the right place. One of the things about Lowell Observatory that's unique is that we're privately owned. I'm not officially associated with any university or other agency. So our scientists have the independence to work on whatever they want and the support from leadership. The observatory is still owned by the Lowell, or operated by the Lowell family. Lowell Putnam is Lowell's great grandnephew. And he is something he still pushes is, our astronomers, you have the latitude to work on what you want. And also, because we own our own telescopes, you don't have to necessarily put in time on, astronomers still do this, but on our own telescopes, you don't have to put on time, maybe you have an hour, or maybe you have a night or, several nights. But when you have your own telescopes, you can do long range projects, night after night in some cases, or week after week, month after month. And as an example today, Gerard Van Bell has led a study that goes back a couple decades, and they measure precisely the physical parameters of a couple hundred giant stars. And being able to have a better understanding of the exact measurement allows us to model stars better. And one of the impacts of that is looking at the future of the sun and how it might evolve. So anyway, another example is Clyde Tombaugh carrying on and on again, off again search that went on for 25 years, night after night, using a telescope, photographing the sky, looking for a planet, and discovering Pluto in 1930. So that's another, I think, a neat thing to mention about the observatory is that independence and having our own instruments. I mean, our astronomers still use other instruments around the world. Phil Massey, who studies massive stars, I think just this week has time on a telescope in South America. He's not down there now because of COVID, but still observing remotely. But there is a network around the world of telescopes, but owning your own gives you a unique opportunity to do some long range studies like this.
It absolutely does. And we've talked about the phrase applying to Lowell of America's Observatory, as we like to call it, which is really fitting. And this, I think the attributes, really go back to the beginning there. Not only now, especially do you have, you've got historical instruments and you've got a very large aperture cutting edge telescope and you've got things in between, and you have such a range of expertise with the astronomers. This all works if they're all really smart, which they are, fortunately. but you've got people doing solar system science and extragalactic stuff, a lot of stellar astronomy. It's a sort of a self-contained unit, Lowell Observatory, that is specializing in things that its instruments and its people's capabilities can really do damn good research with, in a little universe all of its own, which is really unique. The power to make those decisions and study such a range of things with a variety of techniques and instruments that you don't see at other observatories. It really is special in that way. And I think the seeds of that go all the way back to what was VM Slipher, I think, was at the observatory for 56 years or something like that, so that kind of length of study and of institutional knowledge building up is very unique, it seems, as well.
And it really started, right here where we're sitting. Lowell had borrowed a telescope for a year or two, but this has been, this is what started all, really. I think, Sarah, are you going to move the dome?
Yeah, I'm just going to give it.
So, and that squeaking again is the dome moving, and it squeaks because it's sitting on Ford tires. One of the many classic parts of this telescope. It's got so much personality, and the fact that it sits on tires. And in fact, behind me here, you can see the hubcaps of those tires. And if you could zoom in, you can see Ford on the hubcaps. And it really is symbolic of Lowell Observatory. There's so much personality to the place, and character. And that's why it makes it so fun to do these programs, because there's endless stories and personalities. And then the discoveries, of course, the discoveries are great. So, we're saying it started with this telescope. Let's go back to that year of 1912 and talk a little bit more about, he's doing these exposures of the spiral nebulae for hours, dozens of hours in some cases. So, what was the point? What did you find out of that?
So, just to look at the year for just 1 second, I mean, this is something you can't make up in a screenplay. Nobody would believe it, that he can discover the nature of the interstellar medium and then 6 months later come to a major point of discovery of working with these spiral nebulae. And he discovered that they were most all of them. Now, they're random motions, on smaller scales as well. But he essentially, like the Andromeda galaxy coming toward us and eventually merging with the Milky Way, that's an exception. But he found that most all of these galaxies are moving away from each other and from us at very high velocities. And therefore, he really, in 1 year, discovered the interstellar medium and the nature of the stuff that is between the stars in the Milky Way galaxy. And a few months later, the fact that the universe is expanding. The key point of cosmologically of the evolution of the universe, that if you run that film of expansion backwards, you get to a singularity in what we now, it couldn't have been imagined in 1912 right away, but what we now know is 13.8 billion years ago to what came to be called derisively by Fred Hoyle and eventually lovingly as the Big Bang. So, to discover these two major attributes of the universe with the same telescope, the same instrument in different clever ways in 1 year is almost completely unbelievable. It's up there with the miracle year. Einstein had his miracle year, and Newton, went home and worked on a book when the plague, was going around the university. And that was a good year in the long run for Newton, writing what's probably the greatest book in the history of the world, many people think. So that was almost an analogous, unbelievable year, measuring those velocities of galaxies and understanding that the universe is expanding.
And what I find interesting about this is, when Schleifer announced this, other scientists, didn't completely know what to make of it,
Right.
but they did realize that this immediately says the universe is much older and vaster than we thought. And so in 1914, when he really announced some of these findings at a big meeting, WS meeting, I think it was in Illinois, right? Chicago.
I think it was, yeah.
Evanston, Indiana. Maybe.
Yep.
And so he got a standing ovation from fellow scientists. And how often does that happen? They realize this is important. And what I find interesting about it is he's rubbing shoulders and getting a standing ovation from the eminent scientists around the world. And he's working in a place that, up until 1912, Arizona wasn't even a state yet. It was still a territory.
Yes.
So it's kind of, the Wild West, the frontier, the frontier in several ways, really. And to think that he was doing this, this cutting edge research, it's really a neat story. And it really, in the overall scheme of things, it's not that long ago. It's more than a century now, but it's not that long ago. And, when you're just separated by one or two people from, people that knew VM, are still around. And so it's neat to make that connection. It hasn't been that long ago.
It's incredible. It's only, a long human lifetime ago, a little more than that now. And
I think that was just before you started editing Astronomy magazine, right?
It's been, I just never found the exit really in the building, was the problem. But it's been a while since. But he had that breakthrough acceptance and obvious credibility then that was terrifically important and for all sorts of other studies that followed, of course, as well. But, for a while there, there was great skepticism about, who is this guy? How can those measurements be that something must be wrong, initially was the, which is often the case with sort of, eureka moments, if you will, which don't happen much anymore in science.
And then there's that challenge that by this time, Percival Lowell had started the observatory to prove the existence of intelligent life on Mars. And by 1907 or so, scientists were really scoffing. And so in some ways, he kind of changed gears and started looking for a planet.
Yes.
And so, okay, here's another scientist from Lowell Observatory. Oh, that's where they're seeing aliens.
Yes.
So you can see how, and then Percival Lowell was such an outspoken person, and VM Slipher was opposite end of the spectrum. A Western guy from a large family that was a quiet talker and just put his head down and worked hard.
Yeah.
So you wonder if he had a different personality, like a Percival Lowell or an Edwin Hubble, and was more forthright and pushy, how that would have changed. But he wasn't. That was just the nature of who he was.
That was the nature of who he was. And I think it would have been a very different track of all of this research had he been a different kind of, so much humanity is wrapped up in the stories of this science. And how, we all know, how brusque, and Hubble, Hubble was not the, the most popular guy at the party every time, yeah, so that humanity plays a big part in the story of how science goes forward, especially in such a key moment when things were changing so quickly. The definition of the the architecture of how everything was hung on the wall, it was kind of natural to think that that's ridiculous. It can't be right. Just like Hubble's measurement eventually, of the distance to the Andromeda galaxy, which was 1 million light years. Which was 3 times the size of the universe at the time in 1923. So some of these really good measurements and thoughts and ideas and work that gets done that are such breakthroughs seem crazy, until it's clear that they're true.
Right. Well, we've got about 5 minutes left. So let's think about the work that VM Slipher did and put it in context today. And, how the work he did laid the foundation for later work, not just of Hubble, but how we see, the universe today.
Well, I think he's one of the creators of the modern vision of astrophysics and cosmology that we have today, along with Hubble and along with, half a dozen or more others in the turn of the early 20th century, who really established the basic facts of what galaxies are, how the universe is populated with, we now know, about 100 billion galaxies in current cosmic time, how galaxies work, what they contain. They contain stars and gas and dust. They're star-making machines. Stars are nuclear furnaces. Pals like Eddington and so on, worked on a lot of that too. So he was one of the people who really established the modern idea of what the universe is and how it really works. That's a pretty major statement to make about a small number of people in the early 20th century. And VM Slipher, as we've talked about a little bit before, he doesn't necessarily get included with, with Einstein and with Hubble and a few others. He was really one of the people who did the key research that established these big picture topics and how things work. So he's really a very large figure. He deserves to have a very good full biography scientifically written about him someday.
Yep. I think that, that sounds like a great project, Dave. We have a couple of questions here for Sarah, actually. What heavenly body are we imaging on the right?
Some other star. There's 2 stars in the field. I don't know.
Okay, so in case you didn't hear that, there are 2 stars in the field. There's Merope, and this is another one. But she doesn't have the star chart out offhand to know which one that is.
Full disclosure, it's so cloudy that I've got some stars in the Pleiades. I'm not 100% sure.
Okay, so in case you didn't hear that, because the cloudiness also, it's kind of hard to distinguish everything and know which is which anyways. So, it's neat to be able to look at something, but when nights like this, it makes you appreciate, somebody like VM Slipher coming out here every night, and he's doing this in December. And so, willing the clouds away. And when it's clear in the winter, it's darn cold here, but holy cow, the clarity of the sky is remarkable. And we've got just a couple more minutes here. We've got a question. Dave, I'll pose this to you. Are you excited about the James Webb launch?
Oh, yes.
And it's been delayed again, but in the overall scheme of the life cycle of the James Webb telescope and how long it's been on board, we're getting darn close.
We're getting very close. And if you'll forgive me to be so shameless, you can read a full story about the launch and about the capabilities of the telescope by John Mather, who's the project scientist, in Astronomy magazine, which is about to come to you in the next issue here. So, but I'm very excited because, let's cross our fingers, first of all, because it is a very complex unfolding and deployment that has to be done just right, that is very ambitious for the telescope to be launched and deployed in the right way. But it's very exciting. It'll do a lot of incredible things over different areas of astronomy. Exoplanets will get a major boost of discovery. But most exciting, I think, and one of the reasons why it was engineered the way it is from my point of view, is we don't yet know what the formation sequence of the first matter in the universe is. Stars, galaxies, and black holes. Did galaxies come first, stars linked on within them, and central supermassive black holes formed in their centers? Did black hole seeds form first, and then bright matter around them, and so on and so on? We should see one of the capabilities of the Webb is to show us the first stars and galaxies in the cosmos. That'll be a major, major point that we've been working toward since the days of VM Slipher for 100 years.
Well, stay tuned to that. We're all excited about that and seeing how the technology keeps advancing. The old thing about the more you know, the less you know. the more technology advances, the more questions we have and the more things there are to see. Well, as happens every time with this, our time is up. It went really fast. Thanks so much to my fellow Buckeye, Dave Eicher, as I call him, the godfather of astronomy, because he knows everybody in astronomy. He's such a great resource and a great friend to us. So thanks for joining us, Dave.
Thanks so much for having me.
Thanks to Heather Craig behind the scenes for juggling with both hands, making this work. Sarah Bircher, willing the clouds away so we could have a couple quick peeks. Thanks to everybody for joining us. Have a great night and enjoy your holiday season.